Hi everyone, and welcome to this lecture, Lecture 6, Situational Awareness LLMs in Information Retrieval and Agentic Engineering. And today I'm going to talk about how LLMs fit into information retrieval and sort of a situational awareness, sort of giving you a overview of sort of the landscape in 2026. Because as you all know, we sort of live in a time and sort of technology is changing a lot, and sort of give us sort of an understanding is like what's happening and sort of how are all these changes relevant to information retrieval. And to get started, I would say that I'm going to have this lecture series. I'm going to focusing on sort of helping you understand how LLMs fit into information retrieval and sort of agentic engineering, how we work with sort of AI tools for programming. But overall, sort of give you an understanding how all these things fit together to build up to the understanding of AI agents, which is sort of tools that sort of combine information retrieval and tool use using sort of traditional programming to perform actions. And sort of these systems are very dependent on information retrieval and sort of having the right context. So in that sense, I think it's very relevant for information retrieval to understand these systems. And I would even go further and say that the limiting ability of these tools are sort of the context or sort of their understanding, and that sort of relies on their ability to parse and understand the right information. And so we're going to have a lecture series and starting out with sort of giving you sort of a broad view of LLMs in information retrieval. And then we're going to look at embedding models, which are models that sort of gives meaning from text to sort of a meaningful representation based by numbers. And then we're going to look at context engineering, how to sort of understand what is context and how can we work with context. And context is basically for LLMs and humans, right? The sort of shared understanding, which can be text, right? We use to solve a task. What do we think is true right now? And then we're going to look at tool use and agents and sort of how we can fit this together, the sort of understanding fit together to make these agentic systems. And then we're going to look at sort of best practices for AI agents, and then we're going to have a guest lecture. So basically, what's an AI agent? An AI agent is a software system that sort of uses LLMs as a sort of brain and uses information retrieval to get the proper context or sort of understanding in order to solve problems. So it sort of combines two parts. One part is sort of the information retrieval, getting the right context or understanding, and actions using software or sort of functions or like traditional software to perform actions in the world, right? So the agent first understands, okay, what is the problem I want to solve, and then it tries to solve this using an action. And our job is to sort of steer these systems using prompts or sort of text, so we can ask them what to do and sort of steer them when they're doing their work. And sort of, as I said, that the AI agent sort of is the brain for this. And there are many agents, some used for software, some used for other things, right? And they're sort of becoming more and more common as a pattern. And some common agents are sort of Claude Code and Codex, but it's something which is sort of used for programming, and OpenClaw, which is a system for sort of more general agent. And sort of in this lecture series, we're going to focus on help you understand the sort of the architecture of transformers, and sort of the attention mechanism is sort of the sort of key breakthrough that sort of led to all this technology, and sort of understand how sort of LLMs fit into information retrieval and how this can form the basis of AI agents. We're also going to look at how to work with embedding models and sort of identify why we need this sort of context engineering and looking at tools for that sort of retrieval augmented generation. And then we're also going to look at building real agentic systems using actions and skills, and sort of looking at different paradigms in programming, between software 1.0, which is sort of traditional programming, software 2.0, which is sort of training models, and software 3.0, which is more like AI engineering, so telling the AI to build software for us. And I think for many it could be sort of a challenging time or an interesting time, because we sort of have this sort of intelligence explosion in the last, I would say, 10 years, where AI tools become better and better. And I've been working this for a long time and sort of seen this coming. And of course, this sort of leads to interest in the field. And I think one way to think about this is that this sort of breakthroughs in language understanding is really helpful for us, and language is sort of a foundational for intelligence. At least it's sort of a structure we can use for doing intelligent work. So, and when AI agents or like AI systems understand language better, this sort of leads to this sort of intelligence explosion that we sort of see where the AI system seemingly can do a lot, right? And you can think this sort of a search and retrieval of language in one way. And basically, artificial intelligence has been around since when we had computers. So it's been around basically forever. But the sort of latest boom started in around 2010 with systems that sort of, okay, can we see if we can find a way to find a cat in an image? And over time, we sort of got these deep learning systems. There are systems that are larger and larger, and they use a lot of data to sort of train models. And some key terms is sort of artificial intelligence, which is sort of the broader term. And that could have other systems that are not machine learning, where we want systems to learn. And we have deep learning, which sort of is the key technology today, which is sort of large systems, big systems with a lot of data. And over time, we can see this, that the models grow in size and have more capabilities. So instead of having specialized models, we get more general models. And over time, we can talk about a concept like AGI, where we have models that sort of knows everything, and sort of, and then, but over time, we can see that the models at least are getting more and more competent. And I think if you want to understand how we get there and sort of the paradigm and how people think, Nothing is Better Than a Bitter Lesson by Richard Sutton, which is a text about explaining how to think about this. And the idea being that over time, using more compute, more data, and more computers, sort of computing power, and more data, we get better systems. And it's a bitter lesson because we want to be clever, right? We want to figure out what is intelligence, how can I contribute with my clever ideas? And over time, that doesn't seem to work. What works better is sort of figuring out how we can structure our data and structure our like building software that we let the systems learn themselves. And this has been around, and it sort of shows that over time, these sort of large systems win out over specialized systems. Okay, but what do we need to build an AI system? Basically, we need three things. We need hardware to run training something on. And these are something called graphical processing unit, GPUs. They're often made by NVIDIA. We also need structured high quality data to train on. And a common mistake is having low quality data, because the data is the input to the model. This is basically all that matters. Some other things matter, but it's very, very important to have high quality data. And the better quality data you have, the better your model will be. And it's usually better to have less high quality data than more data of lower quality, right? Because the model will learn based on the data. So if you sort of, for instance, in this task, Bekesander made a picture of himself, right? And if you run this project and you have a blurry picture, all the output will be blurry, right? But if you have short images or images where you look pretty, you will look pretty, right? But if you have one bad image, it's going to sort of spoil the output. And that works for all domains, right? So think about this. If one thing to take away is, how do I get high quality data, right? You can get data anywhere, but having high quality data for your task is important. And then you also need code for running. And these are different programming libraries, like using Python. You can use PyTorch and TensorFlow to train your models. But this is sort of kind of well established. So usually you can think about it sort of like you can bring your own data and then you can train a model. And then you can get something like this. This is Bekesander showing up an image of himself made with data using a model called Stable Diffusion. And all these models need to be trained on computers, and sort of preferably specialized computers called GPUs. And these are very expensive. So A100, which sort of standard large GPU, is 200,000 SEK for one, right? And these sort of clusters have thousands, maybe millions, but at least thousands or millions of these GPUs. So this sort of leads to the fact that sort of these sort of large companies with a lot of money have leverage in this space because they can just train bigger models that usually work better. And I talked about data is everywhere, and for instance, Hugging Face is a place where you can find data. And here is a good idea to think about how can I structure the data in a nice way. And this is something that people find is boring usually. I want to train a cool model, right? But actually, structuring your data is how you get good results. And this is sort of usually a mistake that people spend the time like, okay, I'm going to figure out the clever algorithm or something. But usually, if you have good data and a standard algorithm, that usually works better than bad data and a cool algorithm, right? Because you can think of it as these learning systems. They learn based on the data, and we have a lot of experience for that, and a lot of clever people who are building cool systems for that. So if you bring your own data, you can get a lot of cool things done. But of course, there are things you can do with the architecture of the models. But basically, good data is always really, really nice to have. Right, and basically all of this progress comes down to sort of one invention, which is sort of attention is all you need paper. It came out in 2017, and this sort of I think you can speak highly of how about important this paper was, because basically all of architecture for GPT models and other models are based on this. And this is very clever because it gives you this attention mechanism that uses something called query, key, and value vectors to sort of look at the data and see how it fits together. So what happens inside the attention mechanism is it sort of structures a representation of your data inside the model. So it knows, okay, this type of data is looking for this type of data and so on. So then it sort of structures everything. It's like, okay, and I think canonical example, I'm going to Paris, right? And then you can think like going to is looking at least for some kind of some place, right? It doesn't have to be Paris, right? But you can think like I'm going to Mars is highly unlikely. I'm going to strawberry doesn't make any sense, right? And over time you sort of get this probability distribution and sort of mapping out of language. So using attention, the model learns a mapping of language, and then it can use that to sort of generate language. Yeah, and basically, I think understanding this could be nice, and there are some good research for that. But basically, think of it as sort of like representing data as this query and key and value vector that gives you information on how this fits together. Is a clever way. And this is also very cool because it makes it so when you input something differently, then the sort of network can sort of change based on that, right? And give you something differently because how attention works. So it's a very, very cool algorithm. And it also makes it so you can train things using these GPUs in parallel. So this has sort of been a breakthrough. And now when we train systems, you sort of keep the attention the same and sort of change another thing because the attention works really well. Hence the really cool name, right? Attention is all you need. Very good name for a paper and very good algorithm. Right, and based on this attention mechanism, you can train models. So here, for instance, is Swedish GPT, which I made a few years ago. And here's in Swedish, but it says, art is a way to understand the world. In that way, you learn about the world in a deeper level. Maybe you thought of it for a while, or maybe you wonder about things. Art. But we can also use art to understand each other. So it sort of has some understanding of art and some things, and it's a bit experimental, right? And this was trained on Wikipedia and some internet scale datasets. And this was a few years ago, but of course it is a relevant possibility for you to train your own models. There are sort of packages for that, and I think it could be an interesting thing to do, to sort of understand this and train your own small model. But of course, there are other models that are better, like ChatGPT. And in general, I think I was at the release of ChatGPT in November 2022. I would say was sort of the point where sort of people more broadly got interested in AI because they saw this worked really well. So before that, there's a lot of people working in AI, but then it's become way more people working with this. And ChatGPT has a good invention called reinforcement learning from human feedback, where they sort of ask people which is the best way to work with the data, and based on that, sort of the model learns the preferences of humans. And I think this is a very nice way to do it, right? Because at the end of the day, humans are going to use it, so they just sort of decide what's good. And this was sort of one of the clever things that sort of we had models before, but this was sort of one of the inventions from ChatGPT that made it sort of break out, that it had this reinforcement learning human feedback and made it so that the response you get is something that people want, right? Because the models can basically output anything, right? And so you should train them for instructions, so to give you instructions, and also train them for sort of reinforcement learning human feedback to give you something that's helpful for people. And then so the model knows how to give you good answers, basically. But sort of how does all of this fit together in information retrieval? And I think in one sense you can think that the LLM itself, also the ChatGPT tools, are information retrieval systems, because they can sort of find sources online or other ways to sort of get information. But you can also argue that they themselves are information retrieval sources. I think about ChatGPT and other tools that technically they're mostly trained on internet scale data, right? So you can really think of them as a search engine in a way, right? So and that's, so they sort of become an information retrieval system, even though they generate it on the fly, but they are information retrieval system. But you can also plug information retrieval system to them when they sort of act as a brain for information retrieval. Yeah, and of course for ChatGPT, there's many ways it works as an information retrieval system. It can understand different things. It can retrieve documents. It can use tool uses. It can search the web, and in sort of way. And I think it sort of blurs the line. What is information retrieval? Is it information retrieval to make an image? Maybe not, but in some sense, maybe yes, right? But basically, it's sort of a hub or a system that sort of gives you a way to sort of retrieve information. And I think another interesting example is Gemini by Google, because Google has Google, right? So they have access to basically all the websites on the internet. So when you use Gemini, they have a system for information retrieval where they can fetch basically any website and use this as a way to augment the data. So these language model systems like Gemini or ChatGPT are not just a model, right? They are also sort of an information retrieval system and other things on top of the model, right? So this is very, very cool that you sort of can get this very, yeah, you basically have access to all the world's information inside the LLM. And yeah, I talked about this, and I would argue that the LLMs are information retrieval systems, right? And I think this example with the New York Times suing OpenAI because they sort of show that they have sort of copied that they can generate like a article from the New York, the New York Times, shows in a way that they are sort of generating the inside the system you can retrieve this information. So they sort of search through the internet to find, when you ask a question, sort of in a way to find the answer for you, basically. But of course, they sometimes not always do that, but that's basically what they're trained on. But of course, LLMs don't see language the same way we do. So this is the tick tokenizer, which is one used for ChatGPT. And as you can see here, it sort of translates a sentence. Does LLM understand language the same way as we do into these tokens? So basically, the tokens are just numbers, and each token represents some concept, and they can be one letter or several letter subwords, basically. And the more common ones usually have lower numbers, but basically this is a way to map all of language in numbers, because the attention mechanism and the sort of LLMs, the sort of systems, when they're trained or they do inference, they don't use text, they use numbers. So you train a tokenizer to sort of do this transformation, and then this is what the LLM actually sees, right? And the cost of LLMs also, like in general, we have sort of the prices of these systems go down, and usually the best systems are one you can have an API key to use, and you can see like, okay, for 1 million tokens, we know what a token is right now, that could be maybe 750,000 words or around 3,000 pages of text. That maybe costs you $5 for an expensive model, or cheaper for other ones. And over time, the price of this goes down. But overall, the best models are usually available through either an interface like ChatGPT or Gemini, or through a paid API where you pay for how much you use of the model. And there are a bunch of ways to get access to these LLMs. You can use a platform called Grok, which has different models, open source models, and you can use DeepSeek, which is a common model, OpenAI, of course, Google, and NVIDIA. And some can give you sort of free usage, which can be nice to get started. But if you're running small experiments, the price is usually not that high. For, of course, 1 million tokens, that's a lot of words, right? It maybe costs you $1 or something like that. So for experiment, you can get an API key and try something out quite cheaply, right? But of course, humans are limited, but so are LLMs. And one way they're limited is that they have a context. And context is basically the working memory of the LLM. So different LLMs have different amount of context. So one famous one who has a lot of context is Google Gemini, which has 2 million tokens of context. And if you think about this, if this is 6,000 pages, right? And it sort of remembers everything on every page, then you realize this is basically all of Shakespeare or something like that. And this is not something a human can do, right? So we're sort of getting past the point where a human can compete in this sense, right? And one way they test this model is that they maybe take all of Shakespeare and they change one word. And they ask the model if they can find what's wrong in the text. And they usually can. But of course, the context is a trade-off, because it's not only how long the context is, it's also what's inside the context. So you can think of the context quality as something very important and sort of fundamental to this. And this, I think, it's how LLMs fit into information retrieval. That's like, how can we make sure the context is good enough, and how can we add information so the context for our LLM becomes great, right? What information retrieval system can we use so we have a great context for our LLM to do the tasks we want. And another concept that came out a few years ago is something called a reasoning model. And basically, today, most of the best models are all reasoning models. And a reasoning model is a model that before it answers you, it thinks for a while. And it uses sort of tokens to think. And after you think done with that, it sort of answers. And this solved the problem that before you couldn't use compute to get a better answer at runtime. So basically, you just got an answer directly, and it just like was good or bad. But here, we can ask the model to think. And this came from a prompting strategy where we told it like, think step by step. But now this sort of made this into the training of the model. And this is, I think, a very, very clever technique, because it gives the model a recursive way to add context. And you can think of this because the model knows all of the internet. It knows way more than you and me, right? So you can use this to add information. So the model thinks, why is the sky blue? Okay. It has to do something with light, maybe. What do I know about light? And then it adds information from what it knows, right? And over time, it uses this, you can say that and the things, and you think about this, we do it, to tell itself that it's sure or unsure. And then it's like, okay, now I'm satisfied. And then it gives you the answer. And this is very clever. And basically all state-of-the-art models do this sort of thinking before they give you an answer. Because they can retrieve information this way. So it's a very, very cool system. And almost all models use it today. And we did experiments on published a paper on how to look at the medical reasoning of these LLMs. And they're very good. And it's very eye-opening to look at like sort of this reasoning traces in the thinking and seeing that they really, for the most part, think really well. So it's a very, very cool technology, I would say. Right. Now we're going to take a break. And after the break, we will look at different tools for identity engineering or sort of vibe coding using LLMs for coding tasks. So enjoy life during your break.